In our daily lives, we are faced with circumstances which requires our decisions, such as choosing what clothes will we wear today or selecting a perfect breakfast to start our day. To obtain these decisions, we use logic. What is logic? Logic is the study of methods and principles used to distinguish what is correct and incorrect. Logic helps one to think properly so that he or she can come up with a logical solution. If one can learn to be logical, they can be more rational in their decisions. Therefore, logic is important in order for us to obtain the most desirable and favorable decisions in our lives. But what is logic in mathematics? Mathematical logic, which is also called symbolic logic, deals mainly with arguments which are made up of propositions.
Proposition, a declarative sentence which is either true or false but not both. For example, 1 plus 1 equals to 2. This statement will always be true, therefore it will always have truth value that makes its proposition. 9 less than 6. Is 9 less than 6? No, right? Therefore, it will have a false value to make it proposition. X plus 1 is equals to 2. This statement can be true or false. Why? If x is equals to 1, then 1 plus 1 is equals to 2, which makes this statement true. However, x for example is equals to 4. So 4 plus 1 is not equals to 2, which makes this statement false. Hence, this is not a proposition since it can be both true or false. For these two sentences, these are not propositions. These sentences are not declarative sentences. The first sentence is interrogative and this one is imperative sentence, and we cannot possibly get the truth and false value out of these two sentences. Therefore, these are not propositions.
Propositions are represented by propositional variable. Example: 1 is an even number. In this statement, where p is the prepositional variable. Prepositions can also be primitive or compound. Compound proposition: one or more prepositions are connected through various connectors. Example: roses are red and violets are blue. In this statement, roses are red, violets are blue are called subpropositions, while they are connected by n, which is our connector. Primitive proposition cannot be broken down into simpler proposition. An example is roses are red. Now, can the statement roses are red be broken down into pieces? No. So that is why it is called a primitive proposition.
Propositions of compound propositions are connected using logical operators or logical connectors. Katulad kanina, we presented to you a compound preposition in which the word and serve as the logical operator. This video, we're going to discuss to you the 4 basic logical operators: negation, disjunction, conjunction, and implication. First, let's go with negation. In negation, we use the word not, and its symbol is like this, like the curly dash. For example, we have statement P. 1 is an even number. Its negation will become 1 is not an even number. Its propositional form will become like this, which is read as not P. So basically, not is just the opposite of the statement. So we can also say in negation of P is that 1 is an odd number, since odd, the opposite of even. So one thing to remember in negation is that if the statement is true, then its negation is false. And if the statement is false, then its negation is true. The second logical operator we have is disjunction. In disjunction, we use the word or, and its symbol is like this, like the letter V. For example, we have statement P. 2 is a prime number. In statement Q, 2 is an even number. Its disjunction will become 2 is a prime or even number. And its propositional form will be like this, which is read as P or Q. So basically in disjunction, we just connected these two prepositions using the word or. Third is conjunction, and its symbol is like this, an inverted V. So for example, we have statement P. 2 is a prime number. In statement Q, 2 is an even number. Its conjunction will become 2 is a prime and even number. Its prepositional form will be like this, which is read as P and Q. So in conjunction, we just connected these two prepositions using the word and. Last, we have implication. These are used in conditional statements or if-then statements. The example of if-then statements is this: if I did not study, then I will fail. The if statement here is what we call the hypothesis or premise. And then statement here is what we call the conclusion. We can use prepositional variables to represent the hypothesis and conclusion. So we write the statement P as I did not study and statement Q, I will fail. Its implication will become if I did not study, then I will fail. And its prepositional form will become like this. It's just read as if P then Q. So in implication, we use this symbol, an arrow.
Now let's try translating English statements to propositional form. A propositional form consists of propositional variables and logical operators. So our main goal here is to identify the right logical operators to use and to represent each proposition with a propositional variable. So our English statement is you can access the internet from the campus if you are a computer science major or you are not a freshman. So our step 1 is to find the connectives or the logical operators used. You can access the internet from the campus if. So the statement here implies that this statement is an if-then statement, and we use the implication symbol, or meaning that we use the disjunction symbol, not meaning that we use the negation symbol. Also, by locating these logical operators, we can easily distinguish the single propositions connected by this. So for our step 2, we can rename these propositions with propositional variable. So we can say that this statement is statement P, this statement is statement Q, and for our last statement, since negation is the opposite of a statement, we can rename this statement with you are a freshman, since this statement is the opposite of the given statement. And we can represent this statement with propositional variable K. So we now know the logical operators to use and we have the propositional variable. We can now arrange this. So knowing that this is statement P, this is statement Q, and this is our statement K. However, our statement K is the opposite of the given statement, therefore we must negate K. And also, this part of the sentence is the if statement, therefore this part of the statement is the then statement. So the correct arrangement is if Q, then P, and not the other way around. That's wrong. So therefore, our final answer is if Q or not K, then P. So let's try translating propositional form to English statements. Let's say we have this given statement and its propositional form is like this. So in order to translate this form to an English statement, first we must identify the logical operators used. For this propositional form, the symbol for conjunction is used, therefore we must use the word and this symbol is for implication. Therefore, the statement is an if-then statement. So for step 2, we must substitute the proposition or statement of each propositional variable. So if translated, the answer will be like this. So let's try translating this English statement to propositional form in order to check if it will match the given propositional form. So if then, the symbol for implication, and conjunction, and conjunction. This statement is statement Q. This statement is statement P. This statement is statement K. Statement C. So let's just group it in order to avoid confusion. So thus, this match the given propositional form? Yes. Therefore, this English statement is our final answer. Thank you guys for watching. We hope you learned something from us, the Group 5. Until next time.